Hello everyone, my name is Ming-Shen. This is the last talk of the Linaro Connect, and I'm from Baidu X Lab. We are a research lab, security research lab in Silicon Valley. We are in Sunnyvale. I'm a security researcher in the lab. So today I will spend 20 minutes talking about our recent open source project. It's called Rust OP-TEE TrustZone SDK. As you may know, OP-TEE is developed combined with ARM and Linaro. So we built upon the OP-TEE OS and the C API and gave a safer, trusted SDK. All right. I think I don't need to give more background of the TrustZone for you guys, so I will skip this. It's just a bit in CPU. If it is 1, it's non-secure word. If 0 is secure word. So you can split the CPU memory and some peripheral into different words to do the isolation. Okay. Oh, this is this detailed TrustZone architecture. As you can, you may have known that. So we have normal word and the secure word, the different exception level, 0, 1, 2, corresponding to user space, kernel space, hypervisor. And in the secure word, secure 0, 1, 2, 0, 1, 3. And the trusted application, trusted OS, hypervisor for now, and in the secure level, exception level 3 is a secure monitor. So there are some like SVC, SMC to do the context switch. Okay. So as when we're talking about trusted execution environment and the whole ecosystem, there are one specification I need to mention. It is called GlobalPlatform. GlobalPlatform defines the TEE specification, including the system architecture, the internal core API specification, and the client API specification. So OP-TEE is open portable execution environment software stack compliant with GlobalPlatform specs. So, so right now, the ARM architecture complying with the TEE system architecture, and for the OP-TEE, they want to comply with C API and some libraries defined in the internal core API specification and the client specification. Okay, so if you have developed the TrustZone application, you may know this kind of functions. So for GlobalPlatform TEE API specification, they define the life cycle of the trusted application, like how can you invoke a function inside the secure world. So first you initialize the context, and then you open a section of the a trusted application, and you can invoke command within this session. You can close session and open another session. So at last, you finalize the session. So for the secure world, there are several functions which will be called at different state machine or the life cycle of the trust application, like TA create entry point, open session entry point, invoke command entry point, close session entry point, the destroy entry point. So jump back to the design of the TrustZone. So GlobalPlatform actually designed the red layer I point here is a GlobalPlatform OP-TEE client API. They provide the library to communicate with the secure world. And for the secure world, there's a open GlobalPlatform OP-TEE internal core API. So this provides a library for the trusted application. How can you build up a secure world trusted application upon this SDK? So why we propose this project? So historically there are some memory safety issues. So memory safety issue is a well-known security issue in like 10 years. But the memory safety issue in trust execution environment is even worse because we assume that the trust execution environment won't leak any information from this isolated world. But there are some cases like these two blogs describe to like you exploit the memory safety issue and gain a higher privilege, like you can gain the privilege of the secure world. So another blog talking about how to break Android full disk encryption and extract the master key from the trusted world. So when we look at the memory safety issue, there are several workarounds, like you can do hardening and you can also do it in the hardware. But we look at from the programming language level. So Rust is recently proposed like 5 years. A lot of people start to use Rust. Rust claim to guarantee the memory safety and the thread safety from the language level. So what does it mean? It means that if you write code in Rust, you cannot write any code with memory safety issues. So there's a little trick of this, but I would say 99% this is correct. Okay, so what we want to do is to build on the OP-TEE Client SDK and TA SDK to give a safe GlobalPlatform TEE API, Client API and the internal core API. So for this React line, we provide the TEE Client SDK and TA SDK. So together we call it Rust OP-TEE TrustZone SDK. Okay, so when we have this kind of design, how to build up this library. So the first thing is we want to have another target where like targeting OP-TEE OS, not any other like Linux kernel or libstd standard environment. So what we have done is to do some modification of the Rust libstd and Rust std and like compiler building of the Rust compiler, and then we bridge the OP-TEE internal API. It's called libutil. It's a kind of libstd library, but it's very minimal. And the libute is another library, C library for the internal core API. It's for TA development. So we bridge the C library to the Rust we call it Rust foundation layer in green. So upon this green layer, you can build up something like safe trust application in Rust. Okay, and there are some dotted line like libc, Rust, libstd, compiler building, and other libraries is from the upstream project. We make some modifications. And so in the top, the trust application can be built on some third-party libraries in Rust. We call it crates, and also the OP-TEE UT library. So right now we have 2 new targets in Rust compiler and the standard library. It is 64 unknown OP-TEE TrustZone and ARM unknown OP-TEE TrustZone. It's 2 targets. And for the client side, it's quite easy because it's a normal world. It's have the normal libc, so we can easily use ARC64 unknown Linux GNU targets to build the normal world application. And if you want to communicate with the secure world, you have to use our OP-TEE Rust library, so you can like safely communicate with a secure world. So I will mention that later. So all the project is open sourced on GitHub, and there are several separated projects because we focus on upstream project, and we have some plan to like push to the upstream so that the Rust compiler natively will support to build TrustZone application. Okay, so the project structure is quite easy to understand. We have client-side library, TA-side library, and modified Rust compiler, and we also rewrite all the OP-TEE example. The OP-TEE is a safe example, like Hello World AES, OTP random secure storage, and also you want to show that we can not only support the library we provide, we can use some third-party libraries. Like this Serde is a serialized and a deserialized library in Rust. Okay, this is some modification of our project. We have to add new targets, and it is called OP-TEE or target OS, and we have to implement some like how to alloc memory and how to mutex and so on and so forth. Okay, this is an example of how to modify the Rust code to do memory allocation. So it's quite easy, just to bridge the libc malloc to libutel. Okay, and thread, because TrustZone OS, OP-TEE OS currently does not support user space thread, so we have to skip this one. Okay, so if you want to start with QEMU, there are Wiki talks through how to build TrustZone with Rust in QEMU. It's very simple. And you will also provide some Docker building image. So if you are not familiar with Rust build system, so it's quite easy to get started. Okay. There's also some example. So here is a demo example. I just use QEMU as a simulator, and you can for this example shows that you can like use Rust serialization, deserialization to communicate between secure world and the trust world. So we call it a message passing between normal world and secure world. So let me briefly give you some design process of our project. So for the initial design, the only thing we can do is to like give a similar Rust unsafe API we see, like this raw API. And later we have more ergonomic APIs. So right now, for the client side, you can just use some parameter value new, operation new, and the session invoke command. So this 5 APIs. And for the first version of the Trust application, it's quite similar, just the same C code and rewritten in Rust, but it's not quite safe because we just like use a no Mongo C API. So for later, we also provide some ergonomic improvement. So right now, you can only the only thing you have to do is to write 5 functions, 5 Rust functions, and add this annotation on top of this function. So when you compile this code, our code generator will help you to generate this helper code, like if you annotate the invoke command. So the name of the function should be anything, but here I put the invoke command, and when compile this code, the procedure macro will be expanded, and eventually will bridge to the C library. And also, we like combine the configuration. You can config for the trusted application together. Like you can configure version description, some property value, and other things. It's quite easy. This is a simple example of the hello world. So right now, the only thing you want to write is a protocol. So because we have the message passing protocol to communicate between normal world, secure world, it's safer to like use shared memory, and it is also easier to use, easier to pass some complex data structure. So you define the protocol and you define the TA in Rust, and then you define some code in client application. The UUID can be written in a text file, and you can just type make, and the client application and the TA will be make and sign. All right. And this is an example of use some third-party library. It is called Serde. So you can use Serde to serialize and deserialize the application. And also, the Serde support like JSON serialization. So it's easy to like you can come up a JSON structure and pass to the trusted application. Okay. Besides that, we also implement a safer trusted secure storage API for data and the keys. And if you have read the GlobalPlatform specification, there's like a state machine and how to translate between the temporary objects and the persistent object. So we provide all the API in a safer way in Rust. So other example, Hello World is a minimal example. AES is we want to show some crypto APIs we have implemented, and HTTP random and security storage, and later Serde to show the serialization, the deserialization. All right, and we also have like extensive documentations and wikis. You can easily. It's just one page of wikis. You can easily run the application. Also, we also want to make sure the API is safer, so we bring in the automatic testing for the FFA bindings between the Rust and the C. And we have also some QEMU integration tests, but we don't have unit tests for now, but later maybe we will add on. And all the test cases will be run in continuous integration platform like Traverse CI. All right, if you want to get started right now, you can tap this if you have a Docker, you can tap this and run the Hello World. All right, we have some roadmap. For now, we have open source it, and some trust application API design, cryptographic operation, arithmetical API, and third-party grass crate is somehow done. And we want to push modified Rust compiler and SDD to upstream, and make the OP-TEE TrustZone as official targets. And later we will like come up some remote attestation mechanism, and like a firmware-based TPM, and some other Rust-based machine learning algorithm into the trusted application. Okay, that's the TrustZone OP-TEE application for today, and I want to give you a more big picture of why this project is proposed from our Baidu side. So we want to, we already have a project called MesaTEE, which is a memory safe TE. It is a universal secure computing platform. So there are several backends. Right now we only have the SGX backend. So later we want to use this SDK to support the TrustZone backend, so that we can hybrid different TE execution environment to ensure the customer will choose best they want. Okay, so that's all. If you have any question, you can ask now and ask me later if we have time. No, I don't think we have any time. So you can ask me later. Okay, thank you.